test the microphone. Oh, that was probably a bit too loud, but there we go. And yeah, let's go to the Raspberry Pi to start with. There's that power cable. Here it is. There we go. Everything's booting. Console with Control Alt T, and I'll start my stream. There it is. Okay. Now let's full screen this. Out. I'm still learning how to use OBS. Whatever, we'll just scale it down manually. That gives me some space in the bottom. Okay. And why is the stream not running? Usually have an issue with that. Okay, let me just try rebooting it. Where's the mouse? Sudo shutdown -R now. We'll reboot it and we'll see if we can get it running after we do that. Okay, let's also check how are the audio levels this time. If I lean, yeah, this is probably about where my head will be when I'm doing the demonstrations. So this is where roughly how far I'll be from the mic, and the mic is at max sensitivity right now. So I'm just going to talk for a little bit so I can listen after the stream and see if the levels are good. Words, speaking some words. These are definitely some words. Just waiting for the Raspberry Pi to boot up, so I'm going to say some more words and words. Wordy words, and coffee. Okay. So that should give me something to test the audio with. I was taking the Raspberry Pi. Giving me an error, but I think the stream should still be working. Let me just double check that. looks like it's fine. Okay, so let's bring up a console, Control-Alt-T. Control-Alt-T. Oh, there we go. Just took it a minute. I'm going to full screen this so I can see what I'm doing. Oh, that is barely better. Let's just maximize that. Let's try it now. /stream.py. Okay, that's what I wanted to see. And let's see now. I should be able to just connect OBS to. Oh, there we go. OBS connected itself. Okay, awesome. So there's a few things that I wanted to test today as far as increasing the quality of the stream. So we're gonna try some better lighting. I'm going to try adding some of it on the breadboard next to the circuit, and I'm going to try adding, I got these little LEDs from the electronics store that they said were like super bright point sources of light, so I'll maybe see if I can integrate those somehow. Here, I'll set those. And there's supposed to be two different shades. Let's see. Nope, that's not it. I had warm white and cool white. Hope I didn't lose them. Okay, well, we'll forget about those ones for now. And what else do I need? We'll build a small circuit just to have something for the camera to look at. And then after that's done, I'm going to upgrade Raspberry Pi and the camera, but I wanted kind of a before and after before I do that. So this is with the Raspberry Pi version 1 on a Pi 4B with 2 gigabytes of RAM, and I'm going to be upgrading it to a Raspberry Pi 4B with 8 gigs and a camera 3. Where did I put the camera? Oh, there it is. Okay, and oh, I might have left those. I think I might have left those in class. Oops. Oh well, I can buy more. I have one. Oh, no, there they are. Okay, so here's... Actually, I don't want to just lay that on there. Some of the things we'll be experimenting with today. And another shade of those. So one of those is the cool white, one of them is the warm white. And the music in the background is all by Kevin MacLeod. I'm not sure which songs are playing. It's just a random assortment, all by Kevin MacLeod, who I will also credit in the video description. clear this aside and start building a circuit to have something to illuminate, and we'll go from there. Oh, and where did I put those? The other thing that I wanted to try with the servo is 0.1, I want to say they're 0.1 nanofarad. That seems about right. It's got a tiny 104 on it. Let me just double check to make sure that's what I think it is. Oops, where's my browser? There's my browser. Capacitor code 104 is, yes, 0.1, oh, did I say nanofarad? 0.1 microfarad. 100,000 picofarad, also known as a 0.1 microfarad. Yeah. Okay. The point is that these, when added across our voltage rail, should hopefully stabilize it and reduce whatever noise that we were seeing on the line. Okay. Where's my pliers? I think they're in my backpack. One sec. So with these ones, usually I just grip them firmly by both pins. And actually, hang on, let's see if we can just remove the tape from that first. I want to make sure that I pull them evenly, and that's easier to do if the tape is lifted. There. That's not coming off. Do I have tiny blade? Yes. I want to change this music. Space jazz. Let's try that. Okay, so we're going to cut the tape, and hopefully not my finger. There. 0.1 microfarad capacitor, and I'll just add that across the power rails here. After I clean the adhesive off of it. No, it's not all coming off. We'll take it off later. Okay, so we're just going to add it on the rails here. And let's also run the code. Let's full screen this so I can see what I'm doing. And new console, Control-T. Zoom that in so I can see. Okay, and we're going to run, I think it was just /servo. We servo 2 because it's PWM right now, or hardware PWM right now. That's actually very stable right now. And it's not because of the capacitor, because I haven't even connected that up to it. So I might not even need the capacitor. We'll just leave that aside for now, and maybe we'll add them later on if we do need to clean up the voltage rail. But I'm actually happy with how that turned out. Okay, so the other thing that we'll maybe try to do at some point today is I'll design a little 3D printed mounting box for that, for the servo, and we'll print that and see if we can, first we'll print a simple version to test fit it, and then I'll make a better version of it next time. Let's finish setting up that test circuit then, since that's working. Actually, where did I put tiny LED? Oh, here it is. Let's see how that looks on camera. Because this is one of the LEDs that was recommended to me at the electronics store for illuminating a breadboard. So we'll see what we think of that. Where's my pliers so I don't bend this? These tiny wires are making me nervous. This side is actually the lead of a resistor. Oh, you can barely see it on the camera. So this side has a resistor built into it, just at the end of the tiny wire. So this is actually probably easier to work with than what's coming out. Now I've got a tiny wire. Let's move the servo out of the way. Tiny wire. I'm just trying to get that. Actually, here. First. Just to loosen up the fins. screws loosened up. Now hopefully I can get this in with the into the breadboard without ruining it. I think that went in the way. Let's see. We need some wires to apply voltage. So, I think they said these ones were 5-volt tolerant, so we'll try 5 volts. Yeah, I'm pretty sure I tried them earlier with 3.3 and 5, and they're a little bit brighter. Wait, no, it would still be the same current. We'll try both. Okay, so let's try it on 3.3 volts first. So pin 1 in the even row, or in the odd row. Pin 1 in the odd row. Right beside the 5 volts that's going to the servo. Actually, it'll probably help if I show the diagram for this. So the website for this is pinout.xyz, and there's our pinout diagram for the Raspberry Pi. So when I talk about the odd row, I'm talking about this one here, which if you look at the legend for the Raspberry Pi, will be the network ports will be down here, the SD card slot will be up here, and then it'll be on the right side looking down. So that's how to orient the pinout when I'm talking about the odd row or the even row. And then I'll say like the 6th pin in the odd row or the 1st pin in the even row. Just to disambiguate how I'm orienting where the pins are. Okay, so so we're connecting 3.3 volts to the positive rail. And where's the ground pin I haven't used yet? We'll use the one, pin 9, so the 5th pin in the odd row. This to the negative rail, we should see the light. Actually, I don't think you can see it on the camera. I'm going to move it over here. What can I use to hold that? Weight it down. Here we go. Let's try this. Yeah, that'll work. Okay, now let's connect the ground. Okay, that's not making a very good connection, but it is connecting. voltage after. Sorry, I need to turn down this music. As per KVL, it would be the voltage after the voltage drop that is dissipated by the resistor. So we are giving it a higher current, but it's still within the 20 milliamps or whatever that it wants. Actually, you know what? Let's yeah, for now we'll plug this into here. 5 volts. We'll just see how well that works for illuminating things. Okay, so now we've got our 5-volt rail, and I'll also open up a notepad. Here we go. Yeah, let's put that there. Okay. So, we've got 5 volts. Well, I actually don't know any of the specs of this LS or the LCD or LED. Let's just pull up the data sheet. No, I'm not going to waste time looking through this. I already know from, because I did the KVL calculations on it before, so I already know that this one is safe and it'll work on a GPIO pin. So the next change I'm going to make actually will be to set this up on a GPIO pin so that I can turn it on and off. Actually, no. We'll leave it on this one because we want 5 volts. So we... But normally, if I was wanting to actually check that the LEDs were safe on a circuit, I would go and look up the data sheet from the manufacturer or the vendor who I bought them from, and then I would double check the forward voltage. Total voltage minus forward voltage, and then V equals IR. So if we want 20 milliamps, let's say the forward current milliamps, and the total voltage is 5 volts. And let's say suppose these are, I mean, I don't think this LED actually is 2.2 volt drop, but let's just say for an example that it is. So we've got, that's our starting information that we're given. we take the total voltage minus the forward voltage to find out how much is left. And then V equals IR from Ohm's law, which also gives us V over I equals R. So we take total voltage minus forward voltage over forward current. What does that give us? 5 volts minus 2.2 volts over 0.02 amps. And let's just plug that into calculator. 5 volts minus 2.2. Divided by 0.02 amps equals 140 ohm. So we would try and find the closest resistor value to that if we were driving it at 5 volts. But if we were doing it at 3.3 volts, like on the GPIO pin, so we can turn it on and off. Let's see, what do we have to work with? 3.3 volts minus, oh, and also actually these numbers aren't real anyway, because I guarantee that these resistors aren't actually 2.2 volt forward. So this is kind of a moot exercise, other than to demonstrate what I would check if I was actually trying to spec out a resistor that appropriately matches the LED. So we'll do that later when we actually use the white LEDs. Where did I put those? I moved everything off to the side. Oh, here it is. We'll actually check what the forward voltage of these is. Because I think that maybe just having a few of those on the breadboard should be enough to illuminate things. And we will also add a little red blinking light. With, I think that one was recommended at 220 ohm. Oh. Yes. Red, black, brown. Just double check that. Two, 0 times 1 with 1% tolerance. Okay. Pliers for this so I don't mangle it. Maybe I'll move the servo motor off to the side too. I'm done with the calculator, so I'll move that so I can see what I'm doing. can see it. And what else do I need? LED. Just bend the pins on this one. Side has, yeah, that side is the flat end. Okay, so I should have actually probably noted down first that this was the long pin. You can't really see it very well now that it's bent, but also if you look at the LED, this side has the flat end, or the flat side of the plastic casing. Sorry. There we go. I think it's probably out of focus, but yeah, this side is flat, so that's the negative side. And this side has the long pin, so that's the positive side. There we go. That's where the flat side is. Okay, now be careful not to short anything out here and bend any wires. So let's put that in there. Oh wait, I wanted that to be on a GPIO pin anyway. Okay, let's change that then. Because I think it'd make more sense if the GPIO high was when it was actually lit. So let's change this over. So it's, the resistor is connected to ground. Although I will actually quickly connect this up and just show what it looks like anyway. So if that low is connected to ground, then this one needs to go the flat side. There's the flat side. Okay. So the pin, it's being held in the pliers. Oh, I can't reach it from here. Okay, we'll just set it the way it was before. Okay, so that's the negative side there. Okay, so at a minimum, that's what I need in order to get it lit up, is a 220 ohm resistor and an LED connected between VCC and ground. But what we actually want to do is make that, hold over here, let's see how it looks on the stream first. So let's expand this in full screen. Okay, yeah, so I can still barely see. Can I even read out? Can I read the resistor? Hide the window capture. Okay. And full screen. Yeah, I can't see the resistor at all if they're close. If they're that close. Okay. so let's redo this. Here, let's get these LEDs out of the way. And remove that. Okay, so in this case I want it to go to ground through the resistor. There we go. So we'll connect the resistor to from ground, the ground rail, to row 30. And let's take, where's the negative side? Okay, so this side needs to go to the resistor. And we'll connect it over to, I guess it wants to go to row 34. Okay. So it's bridging the gap to row 30 on the other side. And then I need a wire. There we go. Okay, let's pick out a GPIO pin. I'll bring this in front. Move to the top. There we go. Okay, so we want... Yeah, let's go with pin 11. Do we have any reason not to? And that leaves PWM open, and we can even add a second one if we want. So let's go with pin 11, which is 6th pin in the odd row. So right next to our ground pin. There we go. Yep, that is the 6th pin. And we'll connect that to pin. We'll run it under the orange wire. Oh, here we go. Let's turn this up. Okay. Just a little bit. And let's bring up, where's the console? I'm going to just shrink this. There we go. And I don't think we need notepad anymore, at least not for now. Nope, wrong one. Actually, we don't need the pin out either. Okay. There's the keyboard. And we'll leave that script running. So Control-Alt-T to just open up a new one. Control-Shift +++++++++. Okay. And actually, I think I still have a blank script that should work for that. Let's see. That one will blink for a minute on pin 11 though, so let's try it. Okay. So I noticed that the camera can kind of vaguely read the resistor at this distance. The light isn't really changing much. Let's see how it does in the dark. Oh, that's actually... Okay, so the LEDs, when compared with like no light at all, that's not bad. Now, here, let's try moving it closer. No, I think it's out of focus. So that's one of the things that I'm hoping will be fixed when we upgrade to the Raspberry Pi Camera 3 because it has autofocus. So we'll test that out in a little bit. And why is my circuit on? Oh, it's not blinking anymore because I can't see what I'm doing here. My arrow keys. There we go. No, I don't think you can. Maybe if I make it bigger. Yeah, full screen it. No, I think I really need a camera that can actually focus, and that'll fix that. Let's turn the lights back on so I can at least see what I'm doing. For time, it is 4:49, and I have to go at 6. Yeah, so I got a little over an hour left. Okay, so let's try. I guess first let's look up the data sheet for the white LEDs and see what we're dealing with for forward voltage. So let's bring this up here. I assume they'll probably be like these ones, which are 3 volts. I guess I could also test it. Where's my multimeter? See it. You know what? Let's move this LED for now. It's not doing much. We'll bring it back later when it's more helpful. Okay, so let's put this here. Okay, I'm going to reorganize this so that the breadboard sits higher up. No, the backlight doesn't really help much. Whatever. Okay. Let's change the music. Sure. Okay. So we wanted to check this little LED here. 0 because it's backwards, yeah. That's not measuring the voltage drop. Okay, well, we'll just go with 3 volts because that's what the spec sheet says anyway. 3 volts and 20 milliamps current. And we're going to connect these up to 3.3 volts so that we can turn them on and off by controlling them from the Pi. So, where's my notepad? Here it is. Notepad. So we got 3.3 volts minus 3.0 volts. Over 0.02, yeah, it said 20 milliamps, so that'd be 0.02 amps. That so as to avoid confusion. And we got 0.3 divided by 0.02, 15 ohms. So let's see, what do I have for resistors to match that? There's a 22. I'll set those aside in case I don't find anything closer. I'm trying to find 15. Probably the closest I'm going to find. So there's 22. Yeah, that's going to be pretty decent. Yeah, let's just go with 22 ohm. Okay. So we'll use these ones here, which are red, red, black, gold, brown. Red, red, black, gold, brown. 220 times 0.1, so you drop the decimal, so it's now just 22. Still with plus or minus 1% tolerance. And we turn this down a little bit because that's a bit too loud. Okay, so let's take one of these out. Use the pliers and then just bend them gently, just near the base of the component. Oh, I can't actually see what I'm doing on the camera. Oh, let's get rid of the window capture. Okay, so I bent the component lead. Do that a little bit more, 90 degrees. There. Okay, let's straighten this one out. Slide this down here. Let's use the same. Yeah, we'll use the same data line that we used before. Because really what we wanted to see is could we read the resistors? And we know that we can't do that with the current focus of the camera. Although I do want it to blink. So let's connect this up at pin row 35. There we go. And another wire. Yellow. Okay, so you know what? Let's pull up our pin out here. Wrong one. Okay, so we want a GPIO pin. Let's go with 11 and 13. So 11 will be the red light, and 13 will be the white light. So this one over one pin. Because I eventually want to move all of the lighting lights onto a section of the rail where it's all just controlled by one script. So use this one. This is the one. Okay, so let's get this right here. Crank this down. There we go. Oh, the leg is going numb from sitting here. There we go. That's better. Okay, and I need the LED. this a little bit. Actually, let's measure it first. I don't want to bend that with the pliers. There we go. Okay, now let's bring up. Where's the Raspberry Pi? Oh, it's hiding in the background. Okay, so let's just bring it in front. No, it's not. Oh, there we go. Display cap. No, not display capture. HDMI in. There we go. Let's bring that to front. And full screen it so that you can see what I'm doing. Okay. So in one console. Actually, let's see. GPIO 17. Which one is that? 17 is pin 11. Oh, that's the same one. Okay. So actually both scripts will work, but that one's the one that runs indefinitely. So let's use that one. Working. And let's start another console now. Actually, we'll just copy the first script. I set this to... How do I change that? Not scroll down far enough. There we go, visibility. Shit. Oops. See if that works. Okay, now I think it's fixed. I think it was recording the whole time, but I don't think it was actually live streaming. Oops. Okay. Well, good to have that fixed. And let's get back over to OBS. And full screen that, so I can see what I'm doing. Change this from GPIO 17 to, let's take a look at the browser, and I should probably bring that in front. Wait, that was the wrong one. Move to top, there we go. So we want... GPIO 27, since we're using the Broadcom pins in the script. Actually, we'll add a new line in here. And that way, when I want to change it later, I only have to change it in one place. So let's save that. Let's get rid of the pin out here. We don't need that. And let's full screen this. Yeah. Chmod it just to be safe, because usually when you create a new script it defaults to not being able to run it. Actually, let's just try it, because I copied it from another script that did have permissions, so it might have copied from there. Yeah, there we go. So now those will both blink indefinitely. And let's take a look at the camera and see how it's looking now. Can we read the LED or the resistor values? Full screen that. Bring to front. Order. Move to top. Okay, and I mean, for illumination, it's not bad. Actually, let's turn the light on and off. Since this one's for illumination, let's turn it on and off for a reasonably long time. Like 10 seconds at a time. Oops. Parentheses are there. There. Okay, and Control X to save. Yep, and where's my Y button? There it is. Okay, that's actually pretty bright. I think with a few of those, maybe on the edge of the board, and maybe angled inward, I might be able to illuminate circuits from the side. Here, let's try that. Let's take the LED and bend these pins about 90 degrees. Yeah, that's not going to reach, so let's check the pin out. Wrong one, this one. And bring to front. No, that's the wrong one. Why didn't it bring it to the front? Oh, weird. If it's minimized, it doesn't show it. Okay. So we want one on this end. Let's go with, sure, GPIO 26. So, odd row, second from the right end. Oh, I've lost my servo motor. Set it over here for now. Okay, so I need this pin here. Connect that right here. Okay, first the mouse. I need to change the pin. Okay, full screen that so we can see what I'm doing. Cancel that. Okay. I'm killing the script with Control C, since you can't see what hotkey I'm using. But every time I terminate the script, jump to exit out of the loop, I'm using Control C. Here, we just need to change this. It's in Broadcom mode, so we need the Broadcom pins. And So that would be 26. So we'll save that. There we go. Okay, now let's try to turn the lights off and see how that looks. Okay, coffee break over. Actually, let's see how the motor looks with the light on it. Yeah, I think maybe with a few more of those LEDs, I can actually probably... that might be the best solution. Those were, oh wait, but those are 3-volt drop already. So I was thinking for a second maybe I could put more of them in series, but no, I can't. I mean, there is a way that I could put more of them in series if I supply a higher voltage, but there's no way that I can put more of these white LEDs, assuming that they are actually 3-volt forward drop, which they seem to be. I can't put more of them in series, because the GPIO pins will only do 3.3 volts. So, yeah, we'll park that one there for now. But I think I might also be able to do something better with. I mean, I could add additional GPIO pins, so I could have more lights that I can just turn on. And I can also use the high wattage LED. Where did that go? Here it is. This one here. So maybe... excuse me. I inhaled some coffee by mistake. So I've also got these... I can see it. Flame-proof resistors. So these are... 3.3 ohm, 1 watt. So I think when I did the math, the KVL math on, actually here, this one I can find the specs for. So we will, let's move that out of the way. Browser. There we go. This one here. The 2.8 watt high power white LED. If I can get it to load. Okay, so bring in my notepad too. Move that over here. Okay, so we've got. Actually, let's start with total. So for this one, I was actually going to use the 5-volt rail. I have a transistor for this one, so I'm calculating this for later. I have to find where I put the transistors first. But we'll assume 5 volts for this one. we've got our forward voltage of 3.3 volts and our forward current of 350 milliamps. And that's really all we need from there for now. We've got 5.0 volts minus 3.3 volts. That should be 1.7? Yeah. 1.7 volts. Yes. Divided by 0.35 amps. Okay, so 4.85 ohms-ish. Why did I end up with 3.3 ohm? Are these the right resistors? One sec. Double checking my math here because when I was at the store, I found that these were the closest ones to the value that I needed, and it actually was worked out to be like 300 milliamps, but this is lower. So what I have here is 3.3 ohms. I get the idea that it was only... Oh, they might have... Hang on. I might have been going based on... Somehow we figured out... Oh! Right, that's what it was. This was based on... Okay, so there's a whole bit of context that was missing here where I was talking to the guy at the electronics store and we were figuring out exactly how to use this in a circuit to drive it from the Raspberry Pi. And there's one missing component of this. There's a 0.7 volt drop on the transistor as well. So it would actually be 5.0 minus 3.3 minus 0.7 volts, which gave us 1 volt. There we go. That's why my math was coming up different. Okay, so let's bring up the calculator again. So we've got 1 divided by 0.35, 2.85 ohms. There, that's what I wanted, because where's the stream? Okay. Let's move the servo out of the way. So 3.3 ohms. It was either that or I think the next one down was like 2.2 ohms. And looking at my calculations here, we want 2.85 ohms, give or take. Like, it's not going to be perfect, but you typically want to, I think it worked out to, if I had gone with the next value down, it was going to be something like 450 milliamps, which is quite out of spec. So by using 3.3 ohms, what we get instead, so in addition to V equals IR and V over I equals R, we also have V over R equals I. So that will tell us our actual current. So we've got 1.0, hang on, create a new line there. 1.0 volts divided by 3.3 ohms. So 0.303 amps, which is 303 milliamps. So I'm undershooting it a little bit from 350 milliamps to 300, but that should still be plenty bright and better than going over by an extra 100 milliamps, which is likely to cause some damage. But the other thing I could have done, maybe I'll consider doing it on the next trip to the electronics store, is I could get some smaller resistor values as well and put them in series to make exactly, what was it, 2.857 ohms. So I could try and get a little bit closer to that and squeeze that extra 50 milliamps, because that is, I mean, it's not linear, but that's about like 20% of the 20% of the total current gone. So it's getting about a fifth of the current that it wants ish, I think. No, 300 out of 350. Never mind, I'm off by a little bit, but the point is it's 50 milliamps out of 350, so that's a sizable chunk. So I don't know, I'll go to the electronics store tomorrow and see what I can find, and we'll try and get that a little bit closer, but for now we'll start with the 3.3 ohm and see how bright it is. So how am I doing for time? 5:30? Yeah, still got half an hour. Okay. Well, the important part is, oh, why is that? There, something popped up on my screen that was blocking me. The important part is that these are 1 watt resistors and not quarter watt resistors. So I specifically bought the ones that are meant to handle. So this is going to be at 1 volt, 350 milliamps, so like a third of a watt. So I could have gotten away probably with a half watt resistor, but they also didn't have 3.3 ohm resistors in half watt, so I went with 1 watt. There we go. Now I'm gonna have to get creative with the clips as far as how to connect to. Do I have any solder on hand? Actually, you know what? I do have one that's already mounted, so I will just go and get that. I'll leave this here for a second. Wait, why is that not blinking anymore? Oh, there. It's just taking a while. Okay, so I'm gonna go and grab the one that's actually mounted on a heat sink from like way a long time ago, because that way I don't have to solder anything, and that will work with the resistor, and then yeah, that'll save me a bit of time. So I'll be right back. And we're back. Okay, so what do I have here? I don't think I need the browsers anymore. Let's full screen this for now. And get the resistor out of the way. So, we have one headlight module mounted to heatsink. Two headlight module mounted to heatsink. Also, the plastic is starting to yellow from... it looks like that's actually from being in contact with whatever they've got on the underside of those washers that I used. So some kind of plasticizer has started to leach into the plastic, I think. Or, I don't know, maybe it's to do with the sunlight or something, but I would expect there to be less sunlight hitting the plastic under the washers, so I think that's some kind of chemical interaction. And here's one that's not. So this is the one that we'll use for testing. This is the one that doesn't have a lens in front of it. Or, well, it's not really a lens, it's like a protective casing, I guess. Here, we'll set those off to the side, because maybe we'll use those ones later. But I think we just need one to start with. Okay, so I will also need a resistor. And I think I brought... Or no, not a resistor, a transistor. Okay, so let's take a look at the component drawers and see what we have for it. Where did I put those? Because I've got the constant current driver. Nothing else, but actually, yeah, let's start with what we know will work. It would be nice to know where the transistors are. Whatever. We'll look for the transistors here. I need those because I have the driver circuit. I just had it. I brought it down here. Okay, well, here's the power cord, which I will need. And where is... It's a little red breadboard. We just had it. Am I sitting on it? No. LEDs over there. Did I drop it somewhere? must have dropped it. 1 sec. Alright, and we're back. Let's put something nicer on. Okay, and so this here is the circuit that we'll be using to drive it. And I can't really see it all though. This was where the signal wire goes. Oh, I don't have any of those wires that I used. I should be able to just use a metal wire for that though. And these. Power comes in there. Did I take the regulator? Looks like I did. And there's some kind of stuff stuck on the board. 1 sec. Just clean that off. Okay, there we go. Okay, so that doesn't have the voltage regulator. It should still. I'll probably want to add a common ground wire to be safe. But this should still work. Let's try it. Okay, so where do we want to wire up this LED? Let's just pick any two of those. Actually, yeah, let's point it away from the camera for now. Plug this into 40 and this into row 45. And because I'm using a constant current driver, I don't need a resistor for this LED. Normally I would. Normally I would want to use this one here if I was trying to drive it in line with a transistor and 5 volts of power. But this circuit here actually uses 12 volts. And it's designed to drive up to 3 LEDs, but I only have. I'm gonna try starting with 1 for now, just to make sure this all still works. Yeah, we'll use the voltage rails on the side here. No. Damn, I should use the pliers. nothing should happen when I power it up. Let's just confirm that, make sure it doesn't let the magic smoke out. Okay, good. And now I think the last thing that I need to do is connect a data signal onto that little red wire standing up there, or the same row as it. So let's... I want to reach that wire all the way over to the Pi. Let's just pick a different GPIO pin. Let's go with GPIO 16, also known as pin 36. So it's the third pin from the right in the even row. Row 55. Or no, let's put it... Yeah, I want to keep it away from the LED, just in case. Let's put it on 55. And... mail wire. The last thing that I need to do is shrink this down a little bit so we can, I don't need the pin out anymore. And let's make the code full screen so I can see what I'm doing. Control-Alt-T. Come on, where's my console? Did it give me one? I can't see. Let's shrink this down a bit more. Oh, it did. Okay. Full screen that. Zoom, 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 zoom. Okay. Some coffee too. Okay, and on here, what do I want to do? Nano. Actually, let's just copy Blink. Let's use Nano instead of I. And what pin is this one on? Check. GPIO 16. This a little bit closer so that the camera can maybe see it. Nothing. Okay, did I wire something up wrong or... when I took the regulator out. Let's see. is still wired up, and so is the voltage pin. And that's plugged in. Let's just double check our code. Let's try changing this to, what is it, 36? Okay, so we'll change that to board mode, pin 36, and let me just double check on the browser. Pin 36, and that is, that's what I'm connected to. Yeah. Okay. Save. Okay, let's minimize this. Full screen that. Oh, yes. Okay. Okay, well, I will have to troubleshoot that later. Oh yeah, because it's almost, what is it, like, the clock is offset by an hour, so 6 o'clock, I think? Yeah. Disappointing that I didn't get that lit up, but yeah, no, all the connections seem fine. We did get the white LED blinking and the red LED blinking, and I'll try. Maybe I'll do another stream later tonight and update the camera to the camera 3. Because I think the biggest issue is the focus of the camera, which that will fix. Okay, so let's unplug all this. So I'll still leave the white LED connected because we'll use that later for illumination, and I'll probably add a few more. Oh, did we try that one in the dark? Here, let's just see how it looks from the side. Before I turn this off, do I have something that connect as a reflector? Let's see how this, yeah, let's just put some white paper over this and see how much better that does. Oh, that's worse. proper reflector for that. But I think even just having some LEDs at either end of the board is a big improvement. Yeah. Okay, where's my keyboard? Alright, so we'll leave it there for now. Have a good day, and I will see you tomorrow.